Uh, Hello everyone. Welcome to GCP Introduction to Deployments with GCP. We will be starting soon. We are also streaming this session on Microsoft Teams as well for our 2CC sessions. So we will wait for some people to join in, and then we are going to start from there. So kindly be tuned. Okay, we will wait for some people to join in. We will start at 11:05. So it's 11:05, and let's start our session now. So let me start by introducing myself. Uh, my introduction. Just wait a minute. I will just consider some things. Yeah. So let me start by introducing myself. My name is Mayank Kumar, and I'm the Google Cloud Facilitator for this year, and I'm also a member of GDSC-VIT Vellore. Now, today in the session, we will be exploring and learning various ways of leveraging Google Cloud to deploy our web applications. The difficulty of the session is going to be beginners level, so anyone who is starting with GCP or just at the beginning of their cloud journey can be very much able to understand what we are trying to explain here and what we are trying to learn today. So let me tell you about what we are going to learn today. We are going to learn about why do you need to deploy your application to the cloud, why do you need containers, and what are containers. And then we're going to also talk about what are the deployment options that are available to you with GCP, what is CI/CD, and at the end we are also going to talk about what are GitHub actions. And at the very end, we will be doing hands-on practice of whatever we have learned in the session, and we're gonna build a CI/CD pipeline to deploy our application to the cloud. Okay, so let's start with answering the first question: why do you need to deploy your application to the cloud? So let's suppose you have a startup idea and you have built a web application. This application of yours, you have decided right now that you're going to deploy your application on your own machine, and you're gonna get access to the millions of the customers that you are planning to reach out to with just your own machine. So what are the things that you're gonna need? So the first thing that you need to do is you have to buy a very expensive router, and you need to buy a very high bandwidth internet connection so that anyone who is trying to access your computer is able to do that very quickly and with least latency possible. And apart from that, you have to apply to an ISP provider, tell them that you need a static IP address, because IP addresses for every machine are always changing. They have a lease that is acquired from the internet service providers. Now, once you do that, you get an IP address, then you configure your network. You make sure that only your application is visible to the anyone visiting from outside the internet. And there are many more things here, many more things that you need to configure in terms of networking perspective. From a networking perspective, okay. So what more things do you need? As your user base grows, you're gonna see that there is massive number of requests coming into your computer. So what do you do now? You're seeing that the internet bandwidth is not able to support. Then you apply to internet service provider to get even and better bandwidth internet connection. Where then it's you are gonna have, maybe you wanna take a lease line of the uh, fiber optics cable running around your city. So maybe you wanna do that, and after that, your routers are just one router you had bought initially, and that is not able to support all the massive number of requests that are coming in. So you need to buy a more expensive router, one that is capable of handling more number of requests. And after that, you're seeing that okay, whenever you have peak usages, your computer is uh, is not able to handle that many requests. There are spillovers of the requests coming into your computer, and your website gets unavailable to the majority of the customers when there is a peak in the usage curve. So again, then what you do for that, you buy even much more hefty hardware. You buy more CPUs, uh, CPUs with more cores. You buy an industrial grade server at your home probably, and then you're soon realizing that okay, you are also running out of RAM. Then you insert more RAM chips, and you are configuring everything by yourself at your home. And basically, doing all this, you are just exhausted after doing all this by yourself. At this point in time, you might want to opt in for a cloud service provider. A cloud service provider is going to take care of all of your needs. Any hardware that you need, it's going to be available to the click of your button. All the networking configurations is going to be encapsulated inside a very easy to use interface. You don't have to use CLI commands to configure your network. If you have used packet tracer in your networking labs, you must know that you have to define routing tables inside your routers, and you have to configure static IP addresses inside the local address. You have to configure maybe different protocol, like border gateway protocol or OSPF protocol, and likewise for internal communication within your network. And these things you have to be configured by yourself if you are the owner of the network. But you can rent all these things from a cloud service provider, and you don't have to worry about these networking aspects. All you need to do is configure that okay, who should be able to access your web application, and what should be accessible. All these things are available to you in a very easy to use interface. We are soon going to do hands-on, then you're going to see how easy it is to configure these things on a cloud service provider. So when you use a cloud service provider, in case here we are going to use GCP, all you do is you put your code onto the servers, and you run your code. You run your code, or you use a specific service of the cloud service provider where they run your code. They are responsible to run your code with the configuration that you have specified. So all you need to worry about is your code and your application. So this is in just why you need to use a cloud service provider. So this is why you need cloud service provider. And now let's talk about what more things that you need with your application. We are talking about just the web application till now. We never discussed about maybe you need a database, maybe you need a caching service, maybe you need a Redis instance, and maybe you also need a Postgres instance with your application. So what you do in these cases is that buy more servers and you connect each of these servers to your main machine, that is the web server, if you're hosting it yourself. But when you use a cloud service provider, these things are being managed by the cloud. You can rent these services being managed by the cloud service provider itself. We are gonna be using the SQL service provided by GCP. So there you will see how how these things happen. So any of your needs that you have, very specific needs like caching software, or maybe big data analytics tools and services, and maybe database services, you can use some managed services with the cloud where you don't manage the servers, but you just utilize them as per your needs. This is another service that are provided by Google Cloud and other cloud service providers. You can very much leverage. So now let's answer one more question of yours. What are containers? This is the buzzword right now: containers, Kubernetes, orchestration. But before you understand all of those concepts, you need to understand what are containers first. So containers are isolated silos where you are able to run your application independent of other applications running on your machine. So when we talk about container, it's an virtualization tool. So what is virtualization? Virtualization is a way where you can um, you can give the impression to each of the software running in on your machine that the resource it is utilizing, for example, network or the storage storage it's going to be utilizing, it's separate for each of the softwares. So this is kind of like, it's not exactly the definition, but you can get a better understanding with this concept that virtualization is where you virtualize the resources available to the system. That is, you abstract out the networking aspects or the storage aspects of your machine, or many other things are there that your app might utilize, and that your app might utilize, and it needs it to be segregated from the other machine. So this is where virtualizations come in. And inside a container, as I told you, it's isolated from the other environment. So what your application needs is it's the dependencies and the binary builds and the libraries that your application depends on are encapsulated inside the container itself. So let's suppose you have two applications, and all of you must have worked on C++ at some point in time. So let's take it like it's totally hypothetical example. Your application depends on IOStream library, and there are two versions of IOStream: IOStream 1 and IOStream 2. So your application 1 depends on IOStream 1, and your application 2 depends on IOStream 2. But on your computer, only one of these versions can exist. So here in this case, you might want to use containers so that the IOStream 1 can be shipped with app 1, and the IOStream 2 can be shipped with app 2. Sorry, did I mess it up? I meant IOStream 1 with app 1, IOStream 2 with app 2. Okay, so these dependencies are segregated, and the containers itself encapsulate the libraries that the application depends on. So even if you have a third or fourth or fifth dependencies, there is not going to be any conflict between each of your applications running. So all of your code and dependencies run inside isolated environments without interfacing with each other. Of course, you can put in aspects where each of these applications are interfacing with each other. It's up to you. You can read more about it. Uh, uh, or maybe ask me during our other sessions, or we can have a very good conversation about this. But when we talk about basics, these are the concepts that you need to understand while you are understanding containers. So let's move forward and understand what are the benefits that we can get out of using containers. Why we need containers is for agility, portability, and rapid scalability. As you just saw, you have an application that you have developed. Now, you need to deploy this application, maybe put it somewhere else. So, when you're working in teams, you have developed an application, and you want another developer of your software to test that application. All you need to do is give them the container image. We are going to soon talk about what a container image, and we're going to talk about it in detail. So don't worry about it. So you give the container image to another developer of yours, and that developer does not have to install the dependencies. All he has to do is run your container image, and he gets the application set up on his machine, and he can just test the application, maybe test out if password fields are working properly or not. When he clicks on submit, pages are submitting or not, all the things that you generally test out. So the integration between the testing and the development team gets much more agile and easy, right? So this is where agility comes in when you're using containers. Now when another aspect linked to it is portability. Once you have a container, you can just ship it around anywhere. You have a container, you can put it onto multiple machines. Like suppose you have Ubuntu running on my machine, and one of your friends is running Mac OS. So you can just give the container image to your friend, and he can just do uh, Docker run or whatever container runtime he is using, and he can just run the application on his machine without even worrying about installing the dependencies. Like if you, let's say you are running an Node.js application, you need the other person to have Node.js installed. But when you use containers, you don't need to install those dependencies. All you need is is the image, and you just do Docker run, and it starts up. Everything is up and running, and you can start with your work. That's the kind of portability containers provide us. Now, when we use containers, it also provides us with rapid scalability. Now, you might wonder if you might have used virtual machines in your daily lives, right? So maybe you have used virtual machines running different operating systems on your machine. Like you have one operating system, you have Windows, you have Kali Linux running on one machine, you have Ubuntu running on one machine, you have Debian running on one machine. All these things have to be installed. They take time to boot up all these machines, and this also solves the very same problem of portability. But the time taken for these machines to boot up and provide you with these services is very high, right? It takes a lot of time for these to boot up. So when we talk about containers, we saw it does not have any kernel. It does not depend on any of those dependencies. Like in the OS, you need something to interface with the host operating system, which is usually called an hypervisor. There is no need for an hypervisor. We have something called a container engine, which is much more easy to use, and easy to install also, and it's much more faster. In a sense, containers are much more faster to run and start. Okay, you can just stop and start containers very fastly, very quickly, and you can hence start like 100 containers on your machine in matter of seconds. So this is the kind of scalability containers provide us. And just imagine when you are handling like millions of requests, and you need to handle more number of requests, and you want to replicate your application fastly, quickly, then this feature is going to be very much of use to you, right? So this is where rapid scalability comes in. Now let's talk about what are container images. Now container images are specification of how these isolated environments which we are talking about has to be set up. You need Node installed in your Docker container image, right? You need Python installed in your machine when you are running the application. All these things have to be specified inside a Docker container image. Sorry, not Docker, a container image. And this is all these things, and how these things have to be specified are detailed in something called container image specification. Now, this is all of jargon that are very core in terminology, but in practical use cases, what you're going to see, you write all these information of how your Docker images or how your container images have to be built inside a Docker file. You specify, okay, install Python, save the source code here, install these dependencies, install Python, install Node.js, and maybe use Ubuntu's image. get Ubuntu's libraries. All these things have to be installed, specified inside a Docker file. Then you do a Docker build command and you the build a Docker image from specifications inside the Docker file. Then you have a Docker image with you. After that, the image is ready to ship. All you need to run this application is do a Docker run with the Docker image name, and it's gonna be ready to ship across all the platforms that are available. Okay, now let's talk a little about what are Docker container engines. Now they are sorry, did I say Docker container engines or what are container engines in a sense? Okay, so what are container engines? Engines are the like I can show you the diagram. It will be much more easier for you to understand there. This a container engine sits between your host operating system and the containers running on your PC, right? So all the interactions between the host machine, like using the internet and using your storage space, and all these interactions are relayed through the container engine. So this is, in a sense, is what a container engine does. It is responsible for all the interaction, and it is also responsible for running the Docker images, or any of the container images. So there are various container engines that you are going to see in daily life. What people are using: Docker, LXD, Rocket. These are some of the popular ones. There are other container engines, but you are going to see most of the people using these things. And most popular of these three is Docker. And Docker is a lot of things. It's a Docker image, Docker container image format is there. Docker container image specification is there, and all these things are somewhere linked together as a Docker tool suite that you use in your daily lives. So let's talk about this, and let's have a quiz first. Now I'm going to ask you a question. Which of the following is not a container engine? Guys, can you answer this question? I will look at your answers in YouTube chat and on Teams chat. So please do answer your. Okay. Okay, guys. Please be interactive and try and answer this. Guys, please be interactive here and uh, come on. We just discussed about this, and I think you guys should be able to answer this, right? And I just have mentioned this quite a few times right now. It's pretty clear from this. Okay. Right. So Sai and Ishank are saying Ubuntu. So yeah, that's the right answer. Ubuntu is an operating system. It's not a container engine. So all of you guys who answered B are correct. It's Ubuntu that is not a container engine. It's an operating system. So now let's talk about another topic of our for today. It's what are the cloud offerings from GCP that you can use to deploy your application. From last session, you might remember me discussing IaaS, PaaS, serverless, and hybrid models. So, what are the different offerings of Google Cloud? So, we have compute engine, which is basically virtual machines. You can rent virtual machines from Google. Then there is app engine, that you can just use for deploying your code onto the infrastructure. And Google is responsible to deploy your code with the specification that you have given. Now we have container run that allows you to run your containers onto the cloud. And then we have Google Kubernetes engine that allows you to orchestrate containers onto cloud into different clusters across the world. We are going to discuss about Google Kubernetes in a while, and also about Google Cloud Run. These two are very new concepts and are very useful in daily life. So let's talk about it a little later. So let's talk about compute engine. What a compute engine? Compute engine provides you with virtual machines where you have a class of virtual machines to choose from. You have general purpose computing machines, you have memory optimized computing machines, you have compute optimized, and you have general purpose also, as I said. So all these classes are there. From each of these classes, you have various options or various specifications that you can choose from. Maybe 2 GB RAM and two virtual CPUs and 4 GB RAM. There might be various classes of these configurations that you can choose from. Once you go on to Google Compute Engine panel, it's going to be very evident from you from what I'm talking about. So Compute Engine allows you to do that. You also have the option to attach SSDs to your machine, or what kind of network bandwidth you want with your machine. All these things are going to be available to you. Now, now this is about Compute Engine. Now let's go ahead and talk about what is serverless. This is a buzzword, right? We have been hearing about, we have serverless compute, and they are very good. They are very good in managing your load, and they are very useful to you. It's very true that computing is very useful to you. You have very nice and easy to use interface when we talk about serverless compute, because you don't have to take the hassle of configuring everything manually. When we talk about virtual machines and you want to add more instances to your machine as the load grows to your application, you might have to do a lot of configuration when if you're using compute engine, right? But with serverless compute, the job of adding more instances to your application and servicing those requests as more users come to your application is done by Google Cloud, and you are not responsible for it. You don't have to manage the infrastructure. Hence, all these concerns are delegated to Google, and you can only think of the goal of yours, that is speed to the market and your core business logic associated with your application. You only need to be concerned about this. Hence, yes, hence it's gonna be very useful if you have a startup and you want to deploy your application very frequently onto the cloud, that you go with serverless compute. We are even gonna be deploying our application with serverless compute option, that is App Engine. Yes, very soon we're gonna talk about it. So let's talk about it. What is App Engine and why it's gonna be useful, and why we are choosing that for deploying our hands-on deploy our application during our hands-on session. So, what is App Engine? App Engine is a PaaS platform that allows you to deploy your code without worrying about any configuration of installing maybe your language runtime. Like if you are using Python, maybe you want to install a Python interpreter. If you're using Java, you need to install JVM and stuff. So all these things are managed by Google itself. You don't have to do anything, right? So App Engine allows you to just worry about your code and forget about the rest. App Engine also allows automatic scaling. So as more number of users come to your application scales out. And you have options available from a variety of languages like Node.js, Java, Ruby, C Sharp, Go, Python, and PHP. And you also have the option that you can bring in your own language runtime. It's not a very, but little advanced concept, and we will not be covering it during this session. But yeah, of course, you can read about it on App Engine's help page. Now, let's go ahead and talk about GKE. We talked about Google Kubernetes Engine, right? Google Kubernetes Engine is a managed service for using Kubernetes with Google Cloud. Right. So what is Kubernetes? Kubernetes allows you to orchestrate your containers in a distributed fashion all across the world. So what you do when you're using Kubernetes is you decide on data centers all across the world based on where your applications are gonna have its users. Suppose you are deploying an app, your company has customers in United States and in India, and you have decided that okay, you want your application to be available to the people in United States and India, and it should be offered with minimum latency and high availability. Right. So you have 5 regions in US, maybe 2 regions in India, and you want to deploy your application across both of the uh, across all these 7 regions, right? So there are going to be specific PC clusters in all of these 7 regions, and you need to orchestrate okay where you need to deploy more application because you are having more load. And as we talked about about App Engine, that is auto scaling, and GKE also allows you to auto scale your application. So that, let's say in United States you are having a very special sale. So GKE will allow you to configure your clusters in United States to, to scale out to handle that extra load. Whereas in India, everything is as usual, and you don't need to worry about the clusters in India because you don't need to scale out at this moment. You have normal people running into your application and using your application. So this is what is GKE. Now, what are the various services that Kubernetes offers you? So let's talk about that a little. So Kubernetes allows you to schedule your application like how, as I told you, like you have a sale coming in, you want to schedule more nodes for this, right? So you just schedule it using Kubernetes. You might want to monitor how is the health of these application. Okay, has an application crashed for some reason? Are all the applications running on your network active right now? Are there any failures? Is the database accessible to all your application? Is it not? As I told you, Kubernetes allows you to scale your application as per your needs. Much more, if your application needs more space, much more compute, you can just configure it to scale at particular moment in time. There is load balancing associated with it. So you have to understand the concept of load balancing. So to understand how amazing Kubernetes is. So let's think about this case where your one instance of your application can handle load for about 1,000 users, right? So if you have 1,000 users and suddenly on your second day you have 5,000 users, for some weird reason that has happened, and the your one instance is not able to handle the load for those 5,000 users. So in that case, you replicate your applications into multiple instances. So if one application was able to handle 1,000 users, so maybe five instances of your application will be able to handle those 5,000 requests. So a load balancer is set up so that everyone who is trying to access your web service is redirected to one of these instances, and the load is managed in an optimal way, right? So first 1,000 users are directed to the first, the second 1,000 are directed to the second. Likewise, all this servicing is being handled by the load balancer, and Kubernetes allowed you to do this natively with just 2 or 5 lines of configuration. So it's very easy to do this with Kubernetes. You can attach separate storage volumes in with your every containers. When we talk about volume, we're talking about storage. You can monitor and log okay what is happening in every application. Okay, maybe one application is getting a lot of users, one application has just crashed. All these things come under lifecycle health and logging and monitoring. You can also debug and introspect like how whatever the reasons why an application crashed while you were deploying and orchestrating everything. Another thing is that maybe you have 5 applications deployed on Kubernetes. You might want to restrict, okay, this person should not be able to handle this particular application because he's not working on that application. You can manage that thing as well with Kubernetes with identity and authorization service provided by it. Now let's talk about what is Cloud Run. We have been talking about a framework where you can run your containers in a distributed fashion all across the world. But on the contrary, you also had to configure all these configuration of how you want to deploy it all across the world. Cloud Run is a very easy to use alternative to Kubernetes. It doesn't allows you to deploy your application in a clustered fashion. Of course, there are ways, but in general use cases, just Cloud Run will not be able to provide you with that option to deploy it in a distributed fashion. But if you know that your application is only being accessed from India, it's a good option to go with Cloud Run, right? So you can just deploy your application with Cloud Run. You can just deploy your container. You don't need to configure anything. And Cloud Run provides you with automatic HTTPS. You don't need to even configure HTTPS with your application. You can add custom domains, and since it's deploying containers, it can go with any library and any size. It requires you to write uh, minimum settings and configuration. Hence, Cloud Run is a very good option when you are on tight deadlines and you need to reach out to the market very quickly. So it's quiz time. Let me ask you this question. Which of these options will you go for if you want to deploy your application across multiple regions for high availability and low latency? Right. So guys, I need some responses this time and more than last time, I hope. And guys, so please be active in the chat and I will wait for some time for the application. And meanwhile, if you have any doubt, you can for sure go ahead and throw that in the chat. So please, guys, if you have anything, go ahead and ask me out. Okay, guys, I'm looking in the chat for both Teams and YouTube. So if you have any doubts, you can for sure ask as well. Hey guys, please be interactive and try to answer something. Okay, Mahesh says it's EC2. Any more answer, guys? Um, Wait, any more answers, guys? If you have, please go ahead and put it in the chat. Okay. So maybe if you guys are not interacting, what I can do. So I'll go ahead and tell you the answer. So the answer for this is GKE and uh, GKE and EC2 is actually a virtual machine service provided by AWS and not Azure Cloud. Sorry, not Azure or this Google Cloud. So it's the answer for this is GKE. Now let's go ahead and talk about what are CI/CD pipelines. So when we talk about CI and CD, CI means continuous integration, and you can understand the concept of integration by imagining a scenario. Suppose you're working in teams, and in your team you have decided that okay, this is your application, and each member of your team is going to be working on some particular features, and at the end you are going to put together all of these features, and you're going to test out if everything is working perfectly or not. So in this pipeline, first you planning, then you are coding it out and building it. Then you're testing all of these together, and you're merging all these features into a same code repository. Right. So all of these things have to be done eh, like in a diag fashion. Like each of these have a dependency on the previous task to be completed. So when you want to automate this whole pipeline of plan, code, build, and test, you do go with a continuous integration pattern. Now, once you have all the changes merged together, you want to deploy your application, right? So what you do is you containerize your application and put it onto the cloud, and your application gets deployed and is available for everyone to use. But this development phase, this deployment phase where you want all of the changes that you have made or the bug fixes that you have made to be deployed instantaneously and continuously. This need is solved by continuous deployment pattern. And it is very clear from this cycle that what you do with CI/CD pipelines is first you plan, you code, you build, and you continuously test your changes, and then you release and deploy, and then you operate on your application. And if there is any error, and if there is any bug that is associated with your application, then you again plan on how to fix those bugs. Then you code it out, build, and the cycle continues. This is how you go about with CI/CD pipelines. So let's talk about what are GitHub Actions. GitHub Actions is a tool that allows you to build these CI/CD pipelines on GitHub itself. Many of you must have used GitHub. GitHub is a tool where you can keep your code. It's a, it's a code. It provides you code repositories. So this GitHub Actions can straight away deploy your code from your code repository without you using any other third party services. Now let's go ahead and try to do some practical work. Let's do some hands on practice with whatever stuff we have learned. We are going to be building a CI CD pipeline using GitHub Actions, and we will be deploying our application on Google Cloud App Engine. Okay, let's go ahead and do that. I will stop sharing my screen, and I will screen share my full screen now. Okay. Okay, guys, so you can go on to this repository, and our moderators will put in the chat. And what we are going to do is we're gonna deploy this application that we have here, and we're gonna make CI/CD pipelines for it. Okay, so first of all, what we do is we clone this repository. That we go to terminal. Okay. Now we go to projects and we make a directory. Let's say project 02 and save. Okay. Now we git clone in the current directory. We have the code base with us. Now let's open it in code. Okay. Now let's go ahead and if you remember this code, the code base I'm sharing here is from one of our previous sessions on backend development. So we are here to show you how you can deploy our applications from our older sessions. So we have got the code, and there are a few things that you might want to remove from here. Okay, so the first thing that you might want to remove is the Git directory, because we are going to create a new Git repository. So, and we also want to remove GitHub because we already have some workflows written in this repository, so you don't want to have that. So we have removed those two things. I have already added some configuration things here, and you might not need that. Okay, you need an app.yml. Okay, now you might want to initialize this as a Git repository, Git init. Okay, now it is initialized as a Git repository. Now let's do one thing. Since it's a Python application, we might want to initialize a virtual environment. Python 3-1 enb. Okay, okay, I made a mistake. I think I shouldn't have done this. I should have given it a folder, all these libraries to reside in. No, delete all these again. Okay, is there anything that I have left out? No, everything is deleted, and yeah, this Python env config is there. Okay, so I have removed all the non-necessary stuff. Now I will do is Python env. All these things are there in the env folder. I'm gonna source it. Yeah, source env. Okay, I guess this should be visible now. Okay, wait a minute. Just I'm gonna put.
Mayan, can you share it? It's not visible on YouTube.
Okay, it's not visible on YouTube. Okay. I have screen shared it again. So is it visible now? Is it visible now? Can you put it in the chat?
Yeah, it's visible. Let's wait.
I think it's visible now, right?
Yeah, you can come.
Okay. Now we have to source this. So I will go ahead and I will activate this. So I will just do a quick recap. What we have done till now is we have cloned this repository, and we have put this in the chat, the link for this in the chat also for this repository. And then we have deleted these particular directories, GitHub workflow and the .git directory that gets created by default. We have removed those so that you can create a new Git repository, and we have initialized our Git repository with git init command. Then we have created a Python env, and now we have sourced this env. The next steps are that we have to run a Postgres server on our machine locally to test out if everything is working fine. So, so I could just go inside and I can just run this Postgres. Okay, now Postgres is running on my machine. Now I need to expose a database URL to to my application. So that is database URL equals Postgres. Since why I'm doing this is because this application has a dependency on database URL. You can see it here, right? So we need to give an environment variable database URL Postgres, and the username is Postgres. The password is root, and it's hosted on localhost. Port number is 5432, and it's Postgres. Okay. Now the next thing that we have to do here is we have to run this application and test out if everything is working fine. We can do that with UVcon, or we can just copy this command, right? So that it's okay. Okay, one thing that we missed out is that we did not install the Python dependencies. That's why I'm getting the error. So I'm going to install the Python dependencies, Python pip install -r requirements txt. It's going to take some time. So if you have any questions, you can put those in the chat. In the meanwhile, I can tell you guys that uh, since this application requires a database, I told you that we will need a database being loaned to us from our cloud service providers. So the next steps after this is that we are creating a database with our cloud service provider, and we are going to do that after this. From GCP console, we are going to provision a database. So this is just installed with all the dependencies, and we have written some tests for this application, right? So we're going to go ahead and first check if our application is running without an error or not. All the dependencies are synced, and okay, there is some error. This is a new error. Okay. We are going to go ahead and install the requirements again. Let's see if that's works. All the dependencies are resolved. Okay, let's try and installing it after installing an upgrade. Okay. Let's hope everything works fine now.
Mayank, your screen went away. Can you share again?
Okay. I will do that. Okay, I'm gonna share my screen again. Share. Okay, I'm sorry for that. By mistake, I clicked on stop screen sharing, I think. So we're gonna do those steps again. We are gonna install our requirements.txt. Okay, and everything is installed. Now we have to check our database URL. Okay, we did the wrong URL, Postgres. Now we have to run our application. Okay, it's running perfectly, right? So We are clear on that stage that okay, our application is running. Now the next thing that we have to do is we have to go ahead and you have to run our tests. So we will go and we have to run our test. So we have a command python dash m the pytest. So this is a command you can just copy paste. Okay, so we can see here that our test was successful and everything has passed. So everything is working fine. But how do you go about making a CI/CD pipeline with GitHub Actions? So to do that, what we do is we make a workflow, GitHub workflow. How do you define workflows? You create a directory GitHub, and inside that GitHub folder, you create a directory workflows. Inside that, you can define your YAML files, which are YAML files, which are going to be used to make your workflows. So let's go ahead and make our workflow for this project. We're going to make the directory. Okay. Okay, I created the GitHub directory. Now I'm creating the workflow directory. CD GitHub workflow, right? And we are gonna make a this workflow which we are gonna call deployment.yaml. Okay, since we are actually low on time, let's go ahead and copy paste much of the stuff. And while we are copy pasting, we will go through and understand what is happening with each step. So the first thing, we have a name key. We give a name to our GitHub action, right? So we have given the name deploy to GCP. Now the next thing that we're gonna define is we're gonna define a trigger. Okay, on what action should this workflow run? If you make a push request or if you make a pull request, all these things can be probable triggers that you might want to use to deploy and run your GitHub action. In this case, we want to run this workflow. If you push to branch master, and this push signifies that, and you can even specify multiple branches here inside this array, and this is about what you can do. And let's go ahead and copy paste this part. We will not copy paste the whole thing, only tell the test thing. So okay, let's go ahead and understand what is happening here. Inside every workflow, you have something called jobs. There can be multiple jobs, and here we have defined our first job called test. This can be any name that you give. This is up to you. The next thing is you have to define runs on. This is the base operating system image that you might want to use. After that, we define various services that you might want to use. Here, we want to use Postgres to run our tests. Because as we just saw here, our application depends on a Postgres server. Hence, we have a service called Postgres. The next thing is we define steps. There has to be various commands that have to be executed, various actions that have to be executed, right, with your application. So you define all those steps here. So you see that in the first steps, we have something called action checkout, users action checkout. So GitHub allows you to use predefined actions with your application. Okay, so these actions are going to be available to you with something called GitHub Marketplace. I've added some resources at the end of this repository. You can just go ahead and check this out. There are some App Engine App Engine. Okay, this is a marketplace thing, right? So here are various actions that you can use. These are predefined actions. Okay, so you understood that okay, these actions are predefined and they have a particular job to do. In this case, action.checkout has the job to clone the repository into the current working directory of the virtual machine that is running your job. Okay, so this is the job for the first step. The next action is set up Python. There are various commands, right, to install Python. Like if you're on a Ubuntu machine, you do a sudo apt install Python 3. And if you are on Mac, then you use a brew install Python 3. Right. So there are multiple commands that are there that you have to use to install. And here we can see this thing is available to you just with GitHub Action. So you don't have to write this command. You just have to mention which Python version you want. After that, there is a caching layer that caching action that you can use to cache your pip dependencies. After that, there is something that we have defined. We have defined the way in one of the steps of all the commands that we have to run to run. Okay. So in this case, we have to run pip install our pip dependencies. Then we have to install our requirements.txt. After that, we run our test with the commands Python and Black. We're testing with Black framework, then we're testing with PyTest framework. While we're testing with PyTest framework, we have also defined a database URL, which is this service that we have hosted. Now let's go ahead and create a GitHub repository and see this in action. Okay, so I'm going to create a GitHub repository using the CLI itself to save some time. Create post app. And now this is created. Okay. Now this thing is ready. Now we're gonna commit it. Okay, first before committing, we need to add everything, right? Git commit action. Okay, we did this wrong. We have to add everything, right? So we have to be on our parent directory. Now we are gonna commit this. Git commit action feed actions. Okay. Okay, there is something. Git add git log status. Okay, there is something else also. Okay, yeah. Now we are in our root directory, and now we have to add a code. And now everything has been added to our code base. Our local Git repository. Now we have to do is git push origin master. We are pushing to the master branch. Now we have to go to my repo that I just created. So I'm gonna look into this. We can see there is some orange dot here. You can go here and go with details. Now this is gonna run all the things that we have just defined. Okay. Right now, Postgres service is being set up. As I just told you, Postgres has to run. Okay. The next thing is you have to install the dependencies. Then you have to test with Black. Okay. The next thing is all our tests have passed. We can see that. Okay, everything is good to go, and our integration pipeline is complete. The next thing is that we have to set up our deployment pipeline. To do that, I told you that we need to have a database provision. Since database provisioning can take up to 10 minutes, I have already provisioned a database and I can show you how to provision a database. Right now, I have one database provision and it's running right now. I'm going to create a new database. I can show you, but I'm not going to create it. Now, I'm going to choose a Postgres database. After that, you give an instance ID, you give it a password string, and this password is going to be assigned to the default Postgres user. Okay, you know that data. Postgres has a default user Postgres. You can set the password for that user here. Then you define the Postgres version. Then you define a region where you want your database to be located. I want it to be in Mumbai. I select this. Then you have two options: single availability zone and multiple availability zones. So what are availability zones? Since if you want your database to be available through two data centers, so that even if one data center goes down because of some reason, you can just have your database as being accessible because of another data center that is still active. You go with a multiple availability zone. So when you're doing production stuff, I will always suggest you to go with high availability. But whereas if you're testing stuff, go with a single availability zone. After that, what you have to do is you have to set up connections. Okay. So now when we are testing, we're going to use a public IP address here because we want to test if everything is working locally or not. Okay. So if you have a private IP address, only the application inside the Google GCP network will be able to access it. And there is something called the concept of VPC that we are not covering right now. You can read about it. So there you can have the public IP address, and only those networking nodes inside the public network. Sorry, only those nodes inside the private network can access the database. Now, if we have a public network, we have to authorize networks that can access the database. So we go ahead and add an access. So I'm gonna add the access for the entire internet to access my network. Internet. And I'm gonna give the address 0.0.0.0.0. So this is the CIDR notation for the entire internet. So we are not covering what are CIDR notation. You can read about it. What are CIDR notation, but to specify that the entire internet should be able to access this, you give this CIDR notation and you do done. Okay, this is remember this thing. Then when you're doing production stuff, don't do a public IP address. Always go with a private IP address and configure your network according to that. Now we're not going to create this instance because we already have an instance created, and I have my credentials with me. I can just start credentials. So here is the Postgres URL for that. I can just do export database URL, and I can just run my application and check if everything is working fine. Still, I can just run my tests, right? Okay, everything passed, so everything is working fine. Okay, now this is done. I told you, you can, if you go to a repository, let's go to GitHub again. Okay, now if you go to a repository and scroll down, you have something called App Engine Action. This, as I told you, there is a whole marketplace that you can use. So from there itself, we have this App Engine that defines some automation that you can just use to use just the authorization stuff and just get it done. The GitHub action. So to do this, we will also look into our pre-existing repository, and let's copy our GitHub actions from there. What we have previously defined, it's going to be useful to us, right? So we can go to this and we have this release setup. Okay. Now just we can copy this and we can paste it here. As we can see, we have defined one more thing here, a release. The first job is test, and then another job is release. Okay. Now, to configure this job perfectly, what we have to do is we have to understand all of this thing that are happening here. So before that, to do that, you can just look into this documentation, which is very good. So you start with, you don't need to do this and this. You start with the third one, initialize app engine with your project. Since I'm right now on a project which is uh, already everything is configured, so we create a new project. We call it my project this only, and we just click on create. Okay. Now this project is being provisioned right now. I suppose we can. Okay, and now let's wait for this to get provisioned. In the meanwhile, let's talk about this. We have something called needs test, right? So what we are saying is, we run this job only if the first job succeeds. Okay, if the first job doesn't succeed, don't run this. This is what we're telling here. Okay, so this was that part, and now since our new project is created, we can go in here. Now we are going to follow the steps that were written here, right? So initialize your app engine, initialize app engine with your project. So we go to app engine, and we go to dashboard. It's going to ask us to create an application. We do that. We select which region we want it to be in, and we select India. Now things are getting ready. But in essence, that's all that you need to configure right now. Okay, here we are done with this much. Now the next thing is that you have to enable App Engine Admin API. You click on New tab here. Let's move to my other user. Okay, and you click on Enable. Okay, once you click on Enable, your application is gonna enable the this thing, admin API. The next thing, it says to create a service account. Okay, so to create a service account, we go here, we go to IAM. Okay, IAM, and we go with service accounts. After that, we create a new service account. We call it deployment. Let's call it dep for now. It's okay. And we create. After that, we have to assign it some roles. What are the roles that have to be assigned? Add required roles is there. You can get a list from here. So we go with app engine admin, and then we type in a filter. Okay, app engine admin is added. Add a role, and we use service account user. We copy and then we paste it here, and then we call it service account user. Yeah, it's added. Okay, shit. Can I cancel this? I needed to add more. Uh, so we create a new service account again. Let's call it that one, and let's continue and keep on adding our roles. So we continue adding our roles, and then app engine admin, app engine roles, service account user. We have to add. Mm, Here we have to scroll. Service account user, add another role. Okay, storage admin we have to add next. We add a service account, storage admin. Yeah, this is storage admin, add another role. We have it here, cloud build editor. Okay, now we add one more role here, cloud scheduler admin, and then we can just go ahead and add it as well. Then we continue and we are done. Okay, this dep one is our service account. We can go to permissions and roles, and we can see that all the roles that we have given it. Okay. all the service accounts that are created. Okay, so it's not an issue now. Okay, now let's go to keys. So if you go to our instructions, what does it say? It's okay, it says download a JSON service account key. So how do you get that? You create a new key and you click on JSON. When you click on create, voila. Now you have the JSON that you need to access the service account. It's done. Now let's go ahead. So when you go ahead, you are gonna see this is the job that you need. So what does the job need? It needs an app.yml, secrets, or GCP project, that is project ID and a credential. We're gonna talk about these secrets dot stuff. What is the secrets dot stuff and secrets.gcp, why secrets is there in a while. But before that, let's talk about app.yml. What is app.yml? We can see app.yml configuration file here. We have this hyperlink here, where you're going to see inside app.yml, we define everything that we need. We define the runtime, what kind of instances that we want to use to deploy our application. These things have to be mentioned here. If you go inside this directory, I have also defined this in my repositories. Did I delete it? I guess I did. No. Okay, I have it here. Okay, I have a runtime. I have environment variables. I haven't defined any environment variable because right now we have only one environment variable, that is database URL, and we don't want to add it at this point in time. We add it while we are deploying. In the deployment stage, we are going to see where we are adding it. So we are going to see it soon, and hence it's empty right now. We define a class, instance class, then we define an entry point. So how are we running our application? You can see, wait, this has to be the terminal. Yeah, we are running our application with the command UVCon main app, right? But if we want to specify a port, we can just use with the port flag, and we pass in a port. So what is this dollar and port? And it's basically accessing the environment variable port. So you always let the environment variable inside the of the GCP decide. So you have to make your application like that only, so that the application is able to access the port variable and get the port on which it has to deploy itself. Okay, so this has happened. App.yml is done. This is about app.yml. You can go through this documentation and read more about it, and you can just ping me on Telegram if you want to know more about it or you have any doubts. So this is about app.yml. We can see here that we have some more stuff associated with this. We have to see the steps now. We have already checked out that actions.checkout clones the current repository's files into the current working directory. Okay, so this is what action checkout does. The next thing is adding env variables.app.yml. We have a tool called YQ. Okay, so what does tool.yq does is it can add anything to a YML file. Okay, so if I want to programmatically add a variable inside my app.yml, what I will do is I'm going to use a tool called YQ. So YQ.eval, and then I'm going to specify the command that I'm going to use to add a variable inside or manipulate my app.yml. So what I want to do is, let's go inside app.yml, and I want to add an environment variable with the name database URL equals since we have an environment variable declared with database URL, I can use this $sign command to fetch that from the environment variable. And I will, after specifying this command, I'm going to add one more thing. Okay, the file which to which I want to append it to, app.yml. We can see it has got appended. Okay, so we see that environment variable has this database URL. So this is done. And if we go back to our deployment phase, that's what we are doing. We are downloading this tool and we are renaming it to YQ. Then we are running this command and then we are piping the output to config.yml. Then we are renaming it to app.yml. Then we are removing the things that we downloaded. So this is what we are doing in the first step. The next step is this one, credentials. Okay, not this one. This one. It's taking three parameters, right? GCP project ID. What is GCP project ID? When you go to your project, you can see the, sorry, where is that? Okay, you go to the project, there is something called ID. This is the GCP project ID. And then you have something called secret. Okay, you can secret of credentials. So, like you have environment variables, GitHub has a feature that you can use to store secrets that you want to use while you are using work. If you go to settings and you can see secrets, I have three secrets defined here: database URL, project ID, and SA staging key. In this deployment.yml, what I am doing is let me open this up. Yeah. Okay. So inside this, I have just something called secret project ID. Okay, I have defined it here. Then we have something called sc.staging key. We have defined it here, and we're using secrets.database URL here. So we have defined it here. And once we have defined it here, we can just access it using this syntax. This is what you can see it here. See it here. So this is the project that has already been configured, but now we have created one more repo right now here, right? So we have to configure stuff here as well. We have to go to our secrets. We have to add all these secrets. So the first one is database URL, and I'm going to add it here. What is my database URL? I had it here, right? So just paste. Okay, add the secret. Add a new secret, and I'm still gonna use my older project for this because I have stuff configured there and it's gonna take time and we don't have so much time with this session. So we are gonna go with stuff we have already done, and we can see the project ID is this for my older project. I can just paste it inside my GitHub action. So I'm gonna paste it here. There should not be any spaces, right? So I'm gonna remove those spaces and give it a name. The name for this is project ID. Okay, I've added it. Now we have to add a last secret. It's called SA staging key. I've added staging key. Okay. Now we can go ahead and we have to add the value for it. So if you remember, we downloaded something, right? We downloaded something and it was a JSON file, nice.pixel.json. What are the contents? Let me show you. Serial downloads, and I'm gonna cat the contents. Nice. Okay. Again, and I'm gonna add zoom my screen. Okay. These are the contents of my JSON file. Okay. So if we have this, we can't put this JSON file as a value here. What we rather have to do is we have to convert this stuff into base64 string to do this. Okay, how to do that for all the people who are using Linux? It's as simple as using cat this command and base64. Okay, and you get this string and you can just paste it here. But if you are not comfortable, then you can also use just Google search base64 encode, and whatever you get, the first thing you just do this and you copy it, copy the whole thing. Great. Okay, and then you paste it here. and then you do encode. Okay, you get the base64 string again, and then you can just go ahead and paste it here. But since in this case I'm not using this JSON file, I'm going to use something that I had previously created, and its name was proj02. Okay, and I'm gonna use that. Okay, I have got the base64 string, and I'm just gonna copy and I'm gonna paste it inside this. Okay, so staging key has been added. Now everything right now is configured. All we need to do right now is push it. So our pipeline is created now. Git add git commit -- git added release pipeline. Workflow. Okay, so this is done. We have pushed it. Now let's monitor what's happening. Okay, this hasn't triggered an action yet. What? Something just failed. Something just failed, and it is not telling us what. Okay, I know. YAML troubles. I did not format it properly. That's the reason it was failing. Yeah, I think it should work now. Probably now. Okay. Git add git commit. Yes. Let's push this thing. Okay. Let's go back. Yes, it's running. You can see first tests are running, and if only if tests pass, we are going to go to release pipeline. Excuse me. Let's go to Google Cloud and see what's happening there. Okay, we have to go to App Engine, right? Because things are happening there only. We can go to App. AMI, not AMI. It's inside the serverless stuff. The serverless stuff. Okay, here is App Engine. We go to dashboard. We can see services, and once we enter the right now we are in testing phase, right? Once we are done with testing phase, what we can simply go ahead and do is we can look out for the release phase, and it will be okay. Testing is done, stopping containers. Now it will automatically start the release phase. Okay, release is starting now. So this is the deployment part, the continuous deployment part. So let's wait for it to complete. Okay, now we are in the deployment phase. Now we are deploying our application. While we are deploying this application, we can go into our Google Cloud and see what's happening. For that, we have to go to versions. Once we are here, we can go to logs. Okay. Okay. Once we are here, we need to clear it. And rather than this, we have to look at for cloud build logs. Okay. You're gonna see what's happening in real time. Okay. Right now, the cold build process is going on, and some stuff is being built that you need. Okay. So once you have a tick here, everything is going to be deployed. Okay. So we check it again. If you have any doubts right now, you can put it in the chat. I will look at those. Okay. You don't have any. Okay. I think we have done the deployment. Now let's check if everything is working in our logs. To check the logs of our application, what we do is we filter by GAE application, or we can just go ahead. We can just go ahead here, back to our app engine. Let's go back to our app engine. It's in the serverless products. Yeah. We can simply go ahead to our logs. Since our application has been has since our CICD pipeline has ran successfully, we have successfully created a CI/CD pipeline which is running, and I'm not able to see the logs right now. I'm not sure of the reason why. Maybe it will take some time to come up, but we can be sure that our application is running and everything is working properly. Okay. So if you guys have any doubt, you can put it in the chat. Okay. Okay, guys. So I will be deleting this project for this so that my credentials are not leaked anywhere. So uh, you should also follow the safe practices where you always keep your credentials to the minimal when you're creating it. All the service accounts should have minimal permissions. Be sure to do that properly. So I'm looking at your chat. If you have any questions, you can shoot. Okay, guys. If you have any question, I'm waiting for you. If you don't have any questions, I will end the session.